Okay, so welcome back. Today we're going to look at interfacing with a real-world piece of software like you see here. And this is used in the real engineering world where you simulate a circuit, an electronic or electrical circuit you're going to design, and you test it out, you see how it works, and you can measure some things and see what to expect. And what we're going to do is we're going to write a simple application. We're going to do it in C#. You can do it in Python or whatever you want. That is going to allow us to access some of the data generated in the simulation. If, for example, you want to take the data and do some more analysis on it or send it into a different piece of software. This particular piece of software here is called LT Spice. It's a free electronic simulation software. I've done a series of videos on how to become an expert in LT Spice. One of the things that this does is, for example, we have our circuit here that we've simulated versus time. And what I've done is I have measured this resistor, and the result is this graph here over time, 100 milliseconds or a tenth of a second. You can see the power usage over time as we feed a sine wave into this resistor. You can see it's got a sine wave of power dissipated over time. And what we can do is we can save this data, the values versus time, as a file. And what we're going to do is we're going to write a simple application that will grab that data, parse it, and make it a little bit easier for us to analyze it and to load it into other types of software applications like Excel. So let me show you. I've already run this. What I can do is I can right-click on this chart and do File and Export Data as Text, and it will give us a simple text file of the time and voltage values. And here is the application we're going to build in this video. And what it will do is it will allow us to grab the file that was saved. And here is the open file dialog in C#. Here is the text file that was saved. And we can open it, and it gives us exactly what was in the file in this text box. And you can see it's got a header, and it's got some time values and some voltage values, or some power values in this case. And what we can do is we can parse that and clean up some of this data. These scientific notations don't work really well in Excel. We have some problems. So we're going to be able to parse it, remove the header, and then convert that into a really nice Excel-friendly CSV file, and also allow us to do some analysis. So what I'm going to do is I'm going to parse the CSV. And what it has done is taken all those time and power values and charted it in the C# chart. Again, I've done a three-part series on how to do charts in C#. It's very, very easy and does really nice work. And we've also saved the CSV file. The results of this all parsed and cleaned up. And we've got a plot. And what I wanted to do on this particular waveform, since it's a plot of power over time, I wanted to calculate the RMS, which is kind of the DC equivalent of this, that would affect the resistor. That, if we're going to figure out what size resistor, you want the RMS value of the power. So what this did is it took all of those values and calculated down here an RMS of 1.75 watts, which needs to be the rating of the resistor. So this application is really nice. You can grab the data and then analyze it however you want. You can do RMS, you can do whatever other frequency analysis or whatever you want. Some of the stuff you can already do in LT Spice, but we're going to make this so that we can make it custom and modifiable. So let's take a look at the application that built this and see how we can bring in a simple text file and parse it, convert it to CSV, and do some analysis. So what I've done is I've brought the raw file that we have exported from LT Spice or whatever application you want to use, and I brought it into a free piece of software called Notepad++. And I really recommend you consider using it. It's free. It's got a lot of functionalities. It will help us in this application so we can figure out how to parse this data when we read it in. So in Notepad++, we've got the file, and you can see the first line is a header, which basically tells us that the first value is a time value, and the second value is a V times I, which is a power value. And we can scroll down and see that there are 655 values in this file. So we got to figure out how we're going to parse this, because ultimately we want to take all these values, these x and y values, clean them up. You can see the x values are kind of crazy. They've got 15 decimal points in the x values, and their scientific notation, and that can cause some problems. So we want to access each of the x and y values, clean them up a bit, maybe make them into 2 decimal points rather than 15, and then we can use them to chart the values and also to analyze them. So Notepad++ is going to be very helpful to do that. So what we're going to do is, in our C# application, we're going to read this entire file in as one string. So this whole thing is going to be one string. Then we want to step through and figure out how we can extract each line into, say, a separate string. And then the next step is we have each line as one string. We want to figure out how we can extract the x and the y values and maybe convert them into doubles or scientific notation or whatever. So how are we going to take this big file, which is one big string, and extract each line and each value? Well, there's a really nice feature in Notepad++ that allows you to look at hidden characters. So to do that, we're going to go over to View, Show Symbol, and we're going to go down and Show All Characters. And immediately it tells you what the hidden characters are in this file. Now you can see at the end it's got a CRLF. Now we did a video previously talking about what this is. It's carriage return and line feed from the old mechanical printers, where you basically, carriage return brought the print head back to the first column, and line feed brought the head down to the next line. So what this is saying, we've got all these numbers, carriage return, line feed, then we go down to the next line and over to the first column. So there's 2 characters at the end, carriage return and line feed, and also in between the values there is this right-hand arrow, and that is a tab character. So you can see between the x and y values there is a tab, and at the end of the line there's carriage return and line feed. So what we can do is we can read this whole thing as a string and use these what are called delimiters, the end of line and the tab between the values, to parse this file into individual lines and then into individual values. So now we have an idea how we can approach this. Let's go and see how we can do that in C#. So here is our C# application. Again, C# Visual Studio Windows Forms. I've done many videos on C# and how to get up to speed on all of this stuff. And you can see what we've got is we've got a couple text boxes here to give some feedback. The top one is going to show us the contents of the file, and then the bottom one is going to give us some feedback as we save files and so on, and any error messages. On the right, we've got a chart. We've shown you how to do that. We've got a 3-part series, how to be an expert in doing charts. And then we've got a label down here that's going to take the values in this file and calculate RMS from all the power values. And then we've got an open file, a parse to CSV file, and an option to remove that first line, that header, and then an exit button. So open file, we'll select the file. It reads it in just as we saw in Notepad++. And then we're disabling this open file because we've already opened it, and now we can parse the CSV, and it saved the parsed value, went through and parsed all of these, saved it to CSV, and it also charted this and took all those values and calculated RMS. So you can see we're going to have some text boxes, a chart, some buttons, and we're going to do some calculations on this. And the big thing is going to be the parsing. Now, it's really important that we understand that when we parse these text values, you know, anything could be in these text files. As you can see, we've even got a scientific notation with 15 decimal points. You have to be prepared for stuff like that when you're parsing text files. So there's going to be a lot of error checking and making sure we've got decent numbers in here, because you can get a lot of nonsense. So we're going to spend a lot of time on doing parsing and error checking to make sure this is all correct. So we're going to exit that, and here is our basic C# Visual Studio Windows Forms application. And we've got our design. We've shown you before how to do all this. Basically, a text box, a second text box. Just drag and drop those from the toolbox. We got the text box. And then we've got a chart that you can drag and drop, 2 buttons, and then an exit button. So those, we're going to double click on those to get the event handlers, a check box to remove header, and then a label. And that's about it. Now, if you're not familiar with that, again, look at my videos on C#. It's very easy, just drag and drop to set these up. So in the code, we're going to have it set up the way I usually do a C# application. I'm using regions, pound region, pound end region. We've got some documentation, a to-do list, and the parameters. We've got some parameters that are going to be available to all of our application. We've got our form 1. We're doing the standard initialize component. We're initializing some UI components like the header checkbox. We're going to default that to true, and we're going to put the RMS in that label. And then we're going to run a configure chart to set up the chart. We'll show you that. And then we've got 2 methods. One is to configure the chart, and one is to take all the data in the file and calculate RMS. And we'll show you how to do that. And then we've got some event handlers for the 3 buttons. The open button, which is basically going to grab the file, open it, and make sure it's all set to go. And then we're going to do the parse button, which is going to take all that data, which is one big string of data, and parse it. And it's also going to calculate the RMS. So let's take a look at this and how we have it set up. Using statement system.io, system windows.forms, these are all generic. And then system collections.generic, because we're going to parse the X and Y values into separate lists that we can then chart. And it's going to make it very easy to do calculations and charting if we have the X and Y values each in separate lists of doubles or scientific notation, whatever. Then we've got system Windows Forms data visualization charting. And that's it for the using statements. Documentation, we've got a to-do list, and our parameters. We're going to initialize this string, which is file text, and that is going to be one string that contains the entire text of the file before we parse it, and we're initializing it to basically a null. Then we have the number of values in the line. In our case, we've got an X value and a Y value in each line, so we're going to set that to 2. In the future, you can add multiple more traces or whatever, but we're going to start with just 2 values. And here is our list of double, the X vals, which is a new list of double, and the Y vals. So the time values and the power vals in this case. And once we've got these, we can analyze them and chart them very easily when they're in lists. And that's about it for the parameters. Then the control goes to the button open click. And what this is going to do is it's going to, as we showed, do an open file dialog, and it's going to allow you to select the file that you want to open and parse. And we've done this before, basically open file dialog. We're going to call it OFD, is a new open file dialog. We're going to set the initial directory. You can set it however you want. I've got it set to D documents file parsing with an ampersand, so we don't have to do double backspaces. And then we're going to do a filter. When we open this up, you can see we do the open file dialog, and it lists that in D documents file parsing, and it's going to show only text files. So we have set up a filter so that it only allows text files to be displayed. It ignores all the other files in the folder. So the OFD filter is text files, parentheses, star.txt, and that's what appears. And then we're going to say star.txt and all files, star.star and star.star. So you can just use it, you can copy this, you can change it to text files, you can add CSV files, whatever you want. And then we're going to show the open file dialog to allow the user to select the file, and it's going to give a result. We're going to do an open file dialog.show dialog, and the result is a dialog result, and if everything works, then you'll get a good result. And then we say if result equals dialog result.ok. If everything worked, then go through and read this in. And the file string is going to be the file name. And what we can do is we can read all of the text in that file and make it as a string called file text. So we're going to do a file.readAllText, and we're going to say from this file, which is this file name, and then we have now read it into file text as one big string, and then we're going to say textbox1.text is whatever that string of those 650 values is, and then we're going to disable the button open button. We're going to say that's false because we've used it. Now all we can do is parse it. And then we're going to focus. We're going to put focus on the button parse button so the user can click on that. And now what we've done is we've opened the file and saved it as this file text global variable. And what we can do is go to the parse button. User presses the parse button, and this is where all the work is going to be done. And again, there's a lot of stuff in here that's just used to debug and make sure everything is reasonable values. So a lot of this code is just for checking stuff. So first thing, we're going to define an array of typically two elements. We've got the x and y values, which hold the strings representing the x and y values in each line of the file. So a string array called xy strings is new string, and it's going to be two values in our case, an x and a y value. So this is going to be two strings representing one line. And then the output path is where we're going to save the CSV, D documents file parsing. We're going to save it as parsed CSV.csv. And then what we're going to do is we're going to have a Boolean. If the user wants the header to be skipped, we're going to call it header skipped, and that's a Boolean. Now we also need to define for our parsing routines the end of line characters and the tab characters for each line. So define the end of line characters to allow separating each line of the file into a string. So the end of line characters, EOL characters, is a new array of characters, and the carriage return is \r character, and the new line is \n character. So we're going to use those in the parsing, and we're going to find another character which is the tab between the x and y values on each line, and that is a \t. And that was that right arrow we saw in Notepad++. So now we can use some logic to determine if we need to strip the header line from the file. If check header.checked is true, then header skipped equals false, which means we haven't skipped the header, which means the next thing we have to do is actually ignore the header. Otherwise, we've already ignored the header, so we're going to say header skipped equals true. So that check header is going to allow us to determine if we should or shouldn't skip that first line. Now we're going to take the entire contents of the input file and convert to a string array where each array element is one line of the file. So we're going to use our carriage return line feed characters to extract each line and put it into an array of file lines. In our case, it's going to be 655 strings in this array of strings, and we call it file lines. And we're going to do a file text, which is that string.split. And we give it the EOL characters, which is the array of characters for the end of line, the carriage return line feed. And we can also use a string split options, which says remove any empty entries. So again, this is double checking. If there's any empties in this file, it will just ignore them. So this will give us an array of 655 strings. Each element represents one line of the file. So now that we've got the file as 655 strings, we can go through and parse them and save a clean version as CSV. So what we're going to do is open a new file using the stream writer. I'm going to call it SW, is a new stream writer at this output path, the output.csv path. So we're opening up a new file to put the parsed data into, and then we're going for each string, I'm going to call it str in file lines, which is the 655 strings in an array of strings. We're going to go through and start by stripping the header, parsing, and then saving the files and charting. So if header skipped equals false, if we haven't already skipped the header, header skipped equals true, and we're just going to continue and go to the next string because we're going to ignore that. So we're going to say, yeah, we skipped it, and by doing this continue, we're just jumping to the next string in the array and ignoring the line. So the first thing we do is we split each line into two scientific number strings with the tab character as delimiter. If any line doesn't contain the delimiter, notify the user and skip it. So if the string contains the delimchar to string, so we're converting that \t to string, and say if the string contains that tab character, then we're going to split it. Otherwise, we're going to go continue to the next line and just ignore it. So we're going to call xy strings, which is a string array, which is the two values on that line. So we're going to split the string using that \t and put it into this array of two strings representing one line. If not, if there's no tab in the line, we're just going to say, hey user, text box 2 append text, skip the following header due to no delimiter, and then we're going to print out whatever that header line was or whatever that line was. So that's just notifying the user, hey, we skipped a line. And then we're saying header skipped equals true and continue. Now what we can do, since we've got the lines, we can parse the x and y values into doubles and save to the new file list. Now, if double try-parse, so we're going to try-parse the x and y string 0 and the xy strings 1, we're going to first start with the x values, and we're going to try and parse it to a double. That scientific notation, try and parse it to a double, and the output value is going to be parsed x, is a double. So if it works, then fine. Otherwise, we're going to append text, say, hey, we couldn't parse whatever that string was. All right. So again, making sure that it's parsable. If not, we're going to notify the user. So that's the x value. We're going to do the same if double.tryparse xy strings 1, which is the y value, and send it out to parsed y. Otherwise, we're going to do the same thing, couldn't parse that value. So now we have saved as parsed x and parsed y the doubles representing the x and y values. And what we can do is add each double to our list of doubles so that we can chart them later on and also analyze them. So each time through, we're going to add the parsed x to the x vowels and the parsed y to the y vowels. And then we're going to incrementally save the x and y values to the CSV file, doing a streamwriter.write line. And it's going to be parsed x plus comma plus parsed y, which gives us incremental lines of CSV numbers as doubles. As we go through that, we are basically stepping through for each line in the array, add them to the list, and then incrementally append them to the file as x and y values separated by CSV. Once that's all done, now we've got the x and y values as lists, and what we can do is we can calculate RMS using our own method and feed it just the y value, just the power values, because we only need that for the RMS. And we'll look at the method we developed for that, but basically it returns a double called RMS. And then what we can do is we've got the x vowels and y vowels as lists. We've talked about this before. We can do a chart1.series, and we're using series 1, points.dataBindXY, x vowels and y vowels. And that's all we have to do to chart those values. Now I did a series on charts, a 3-part series, really simple to do it as long as you understand how to do it. So I encourage you to look at that. So now we have calculated the RMS, we've charted the values, and then we can just fill in the label RMS equals whatever that RMS value to string. And then we can say text box to append text, save CSV to whatever the output path was. So that's it. We've done all the work. Let's just look at the methods that did the chart configuration and also the calculate RMS. Chart configuration, we've talked about this before. We're just saying the chart type is a line chart. The border width was actually the plotted line is going to be a width of 3. Axis X minimum is 0. And we're going to also say we want the format of the numbers in the x-axis to be F2, 2 decimal points. And then we're going to say the label font for the X and Y values is a Microsoft Sans Serif. We're going to crank it up to a 12 size from a normal 8, which is too small. And we're going to do that for axis X and axis Y. And then we're going to clear the legends. We don't want the legends there since we've only got one value. And that's it. That just configures the chart. We've done this before. And then the last thing we're going to do is look at the calculate RMS. And the input is the list of doubles, which is the power values, the list of all the power values in our case. And we're going to do the RMS. Now, the RMS is the root, the square root of the average of all of the squares values. RMS, root of the mean of the squares. So first we have to do is square each value, each power values, add all of them up and take the average, and then take the square root of that average, all right? So it's, as it says, root means square, RMS is the root of the average of the squares. So the sum of the squares, which we're going to need to take the average, is we're going to start out with 0. So for each double value in input vals, we're going to calculate the sum of the squares. It's going to go through and square the value, add it to the previous sum, and increment that. And it's going to take an incremental sum of the squares. So once we've got that, we've got the sum of the squares, and then we can take the average, which is the sum of the squares, divided by how many values we have in the total array, and that's input values.count, and that will give us the average of the squares, all right? And then all we have to do is take the square root of that using a math.square root, and that will give us the RMS, and we can return that as RMS. So now you can add other methods here to calculate other things. You've got the X vals and Y vals in a list, so you can do whatever you want to do any analysis. Here we just showed you how to do a simple RMS calculation. And that's about it for this application. You can use it for a lot of things. You can use it for opening other types of files, doing other parsing and analysis, but this gives you a good idea on how you can do the parsing, what methods are, and how to do some analysis of text files. So that's about it. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.